All right. Hi, everyone. It's so lovely to be here with you on this warm summer evening. But if you remember, not so long ago, just 2 weeks ago, we were in the middle of a series of storms that felt like it would just never, ever end. And as a result of the very wet winter that we had, this is a photo of the Tulare Lake Basin, which has been dry for decades in California, but it actually is now, it's back as a result of all of these storms. But remember, it was really only 2 years earlier that we're still, by some measures, in the middle of a really severe drought. So this, it's hard to see, Governor Newsom is standing in the middle of a nearly bone-dry Lake Mendocino declaring a drought emergency almost 2 years ago today. So this really highlights just the huge amount of hydrological variability that we have to manage here in California, as in many places in the world. And so how do we deal with all of this uncertainty and protect our communities from floods and from droughts at the same time? So one approach that we use this is through infrastructure systems. This is a photo of a desalination plant in Santa Barbara, California, that was commissioned in the 1980s when California was in the middle of a similarly very severe drought. But what happened is there were a lot of permitting and construction delays, and it actually took 8 years for this plant to be finished and come online. And at that point, there was abundant rainfall, ample surface water supplies, and this plant was no longer needed. So it only operated for 4 months before it was shut down. And if you take the huge capital cost of making this kind of facility and you spread it out over only 4 months, you get a very, very expensive gallon of water. So this highlights that we have a really big challenge in how do we develop water infrastructure plans when there is so much uncertainty, both in the hydrological cycle, which is being amplified by climate change, and also in societal uses for water and how those are evolving. And so on the one hand, we don't want to build this infrastructure that we don't need. It's a waste of our valuable resources. It has local environmental impacts on communities. But of course, we really want to be prepared and make sure that we can provide reliable water when we do need it. This is also a problem that has a big human cost. So we often think about water access as a problem in faraway places. But here in California, over 1 million people lack access to clean, affordable, reliable drinking water. And we know that this is a problem also that disproportionately impacts low-income communities and minoritized communities. So it's a really big equity challenge as well. And it's not just in California that we have a lot of uncertainty to deal with. So this is a map of climate model projections of precipitation trends to the end of the century. And you can see all the black dots are places where climate model projections diverge in whether they project it's getting wetter or drier. So we know absolutely that climate change is having dramatic impacts on precipitation changes, but in the local places where people are experiencing the water cycle, we often don't know exactly what the future will hold. So my lab works on these challenges by advancing computational modeling to design resilient water solutions for an uncertain future. And we do this in 3 ways. The first is in advancing approaches and algorithms for adaptive management. And this is a way that allows us to respond as uncertainty is unfolding over time so that we can be more nimble and only build the infrastructure that we need if and when we do need it. We also think about, well, when we do need new infrastructure, how can we make sure that that infrastructure is serving our communities in equitable ways? And we often have to advance our modeling capabilities in order to be able to quantify those impacts on under-resourced communities. And finally, we're also focused on developing partnerships to translate our science from the lab to our communities. And these 3 areas also really motivate my personal motivations for doing this work. I'm a lifelong math geek. I love tinkering with algorithms. I'm really passionate about making our communities more equitable and inclusive places to live and work. And I became an engineer to try to solve problems in the world. So let me tell you a little bit about these 2 areas. So adaptive management is an approach that we can use to address climate uncertainty. So the historical way of infrastructure planning is on the left here called predict and then act. So we make our best predictions of how water availability and demand will change in the future. We add a safety factor and we design for that. But this breaks down for a lot of reasons. It can lead to overbuilding infrastructure that we don't need. We have all of this uncertainty. And so adaptive management as an alternative says, well, why don't we monitor the changes that we need, or the uncertainties, and then decide when we need to develop new plans, and then only if and when we need to, we can adjust course. So that's great, and it's been implemented in water resources for a while now. But what about when we talk about infrastructure planning? The challenge here is that we're talking about large capital projects that have really long lifetimes, maybe 30 years for a desalination plant, 100 years for a dam, and they're fixed once you make them. They're really difficult to change. So we have an element of irreversibility that makes it really difficult to do this adjust part of the adaptive management cycle. So my work has been focusing on ways to try to address this, and we are coming up with an approach that I'm calling learn and then decide. So imagine here, this is a really stylized schematic of precipitation uncertainty in some region that you have going forward. And at the outset, you don't know, is it getting wetter or is it getting drier? But we might be able to wait, say 30 years, have more information about how the climate is changing in this particular location, and then we can make a much more informed decision about what our infrastructure needs really are. And maybe we're willing to incur some upfront short costs to be able to do that. And so my work has been developing approaches to quantify, well, how much can we reduce this uncertainty in the future by integrating methods from Bayesian learning with climate model projections. And then we can combine that with approaches from stochastic optimization and machine learning to design flexible infrastructure approaches. So what do you do once you've learned enough to change course? So that could take the form of modularity, building out infrastructure in smaller increments. It could take the form of designing flexibility into the infrastructure itself. So this is a dam where you can add additional structural support so that you can increase the height of the dam and expand the reservoir capacity in the future if you need to. Or it could be about reoperating our infrastructure systems, so changing how we use them as uncertainty unfolds over time. And this is an approach where we're in the early stages of developing a partnership with the World Bank to help them understand where they really need to be targeting their infrastructure investments for water storage projects in sub-Saharan Africa. So another example is, let's go back to Santa Barbara. So in the previous example, we were talking about learning about uncertainty over these really long time scales, 100 years. But we can also think about, well, what can we learn over the course of a drought as it's unfolding? And this is what we're doing here. And this is a collaboration with Megan Motter, where we're integrating my expertise in decision-making under uncertainty and water resources with hers in distribution systems and treatments. And we are using this to design flexible drought responses that develop portfolios of centralized water treatment technology that you have to build up front, with also decentralized water treatment technology that you can actually respond and add over the course of a drought. And what we find here is that depending on different types of plausible droughts that we might have in the future, maybe a long, mild drought or a more intense drought, that the types of what we can learn and the approaches that we therefore need are really different. So on the left, you can see when we have long, mild droughts, we actually don't need that much more infrastructure. We can manage with what we have. But when we have intense droughts in the middle, we need a bunch of infrastructure up front, and that's because they happen so quickly that we're not able to learn and respond over time. But breaking it up this way and looking at different types of droughts allows us to really understand where are the critical vulnerabilities that we need to be targeting our innovations for. So for example, if we can take our decentralized infrastructure and make it more nimble so that we can bring it online more quickly with technology innovation, we can actually transform our intense drought into a mild drought and again, reduce the need for large infrastructure systems in order to maintain water reliability. And this is work that we're doing in partnership with Santa Barbara, which is, again, considering new investments in desalination. So it's been really rewarding to work with them to think about how to do that going forward. So another big focus of my lab is thinking about how do we design equitable drought solutions. And we advance this by trying to quantify the potential impacts of both infrastructure and policy solutions for water supply and drought management on under-resourced communities. So as one example, if we think about the different ways that we have to respond to droughts, like demand curtailment and infrastructure investment, they all have trade-offs in the impacts of droughts that we are trying to manage. So there's no panacea, and we need to be able to really quantify these trade-offs, and especially the ones that are important to our most vulnerable communities. And so as an example, going back to desalination, we often talk about desalination as a drought-proof solution that will allow us to be completely rainfall independent in our water systems, and that's great. It has a lot of benefits, but it also is very expensive. And so if we think about expanding our definition of water security to include water affordability for low-income populations, then investing in desalination could actually harm water security by making water unaffordable for a larger number of people. And so this is the type of trade-off that we're looking to understand in our work. And so one example of this is we're studying recent drought in Santa Cruz, California. And we looked at, well, what if we manage droughts in Santa Cruz by curtailing demand? And we found a really kind of surprising result, which is that if you curtail demand, then in some situations you see water bills during the drought go up for low-income populations, but down for high-income populations, which is obviously a big inequity in this drought response. And so why is that? Well, there's two ways in which water bills change during droughts. One is that there's a surcharge that is passed on to all customers equally. And then the other mechanism is that the bill goes down from reduced water use. But the low-income households weren't using that much water to begin with, right? They were already not using much more than they needed for their basic household purposes. And so the net impact for them was positive, and the opposite was true for the high-income households. So this really suggests that we need to be thinking carefully about these types of drought policy measures in order to make sure that they're equitable for the communities we want to support. And this is work where we are partnering with the city of Santa Cruz on this work. And I'm also working with my colleague Khalid Osman to partner with Nuestra Casa, which is a community group just down the road in East Palo Alto that does water justice work to think about how we can support water affordability for our neighbors right down the road. And so for me, I think the most exciting thing about the new Stanford Doerr School of Sustainability is really the opportunities to collaborate across disciplines and think about how we can scale innovation and impact through these types of collaborations. So I'd be really delighted to talk to anyone who's interested in working together in these areas. So thanks very much to my lab and to my funders, and I'd be delighted to take any questions.